So this is second generation disassemblable tetrahedron. Second generation means that there are now no magnets. Everything is spring loaded. And there's only one spring system in the middle of the tetrahedron. All the corners are compressed by that spring load, which goes through two bars of the tetrahedron into the rest of the bars, the four bars. And consequently, there are two bars which have balls at the end. That is the far one, and that is the near one. You will see. I start disassembling it for didactical reasons, and then we assemble it. So there are two springs which we have to disassemble, so that we have the choice of two forces. I will tell you why. So now it's disassembled, it will fall apart. But look, it does not collapse completely because there are the corner connectors. These corner connectors I simply disengage, and then I put the bar on the table, so nothing can happen. And this one on the table, and this one on the table. Now everything is safe. I continue disassembling, then I show you how to assemble it again. So this is simply a key holder where you lock in different keys which are on the different rods. Okay, we start with the rods on the table or in the box. I disassemble there that you see in real time how much it takes. I disassemble as well the springs, and we simulate that we just take everything from the box. The box is behind us. I'll show you later. At the end I show you the box. So these key holders should come with the big rods. The big rods are those who carry the ball. Now we have all together what we need. There's nothing more, not more components. The rods are numbered 1, 2. Normally the label is on the 1, 2. There is a number 1 and a number 2. Then there is a 3, 4, which is that one. And the 1, 2 is this one. And the rest is for the side. Okay, so let's start. This is everything disassembled. Let's start. Look at the numbers. 3, 4. 4 is the ball on top. 3 is the ball in the rear. I take the other one away and put this in its almost normal position. So now I read the numbers and say between 1 and 3. Number 1, number 2, number 3, number 4. And 4 will be on top. So 1, 3, bar go ahead. 1, 4. 2, 3. And 3, 4. 3 there, 4 on top. Where do we start? We start connecting everything on the bottom here. I will show you what these rods are for later. It should be to the inside of the tetrahedron. So we connect our corner 1. I'm a little bit nervous because this is a movie recording. So, but never mind. I shiver a little bit. I'm not an actor. So we got this connected. You see, it cannot fall apart. Careful with these cones. They should not hit anything hard. But that is all the caution you have to take. So now we connect the 2-3 rod. Once you have done it a couple of times, you know how to proceed. You know that you can maybe confuse a little bit in the corners, that you later have that key holder on the wrong side, but you will figure out very soon how to do that. So I have the corners 1 and 2 connected. I do the same thing for the corner 3, which is the far one. So the key holders we leave always with the big ones, then we cannot confuse later, and we don't need to search for them and look where do they need to go and so on. So there would be now the bar from 2 to 3. This is the bar which goes from 2 to 3 and is correspondingly marked. Look that the key holders are on the right side. You see there is something wrong, because if we lift this up, the key holder is not in the middle. So we have to remedy that already. Yes, I can do it like that. Now the key holder is in the interior of the tetrahedron. We are almost ready. There's one corner missing. That is the upper one. Now, this is actually the most critical, the only critical part. It can fall down. It never did, actually, to me. It could fall down, but it doesn't. You see, I put these rubber pads there so that I am not endangering the white ceramic cones at the end. Well, if everything collapses now in this moment, this would be bad. This would be really bad, because the corners could hit the granite level of the machine, and that would be a catastrophe. That should not happen. One of the few things that could harm. So, we don't start yet to assemble, I mean to put balls and cones together, but we put the first spring. We put in the first spring. Now you see why there are 2 springs. To start with a small force, and then later, because you see, it's now all under stress, but the bolts are not yet locked in. Now you have the tetrahedron pre-assembled. What to do? We start in the first corner, put these balls and cones in a matching position. Here's the same thing. We hold on these while we move this. We hold on the big one while we move the small one. You look that all is loose and not blocking. Now, same thing here. Let's see whether I put it all the right way. This first, and then the corner 2, 3. In the meantime, the corner 1 is disassembled. No problem at all. I put it in again. There are plenty of these O-rings, so that there are spares in case they wear out. So careful, put that rubber underneath when you do something. If something is, engage again the rod from corner 2 to 3. And now what is missing on top? The corner number 4. Hold the big one, move the small one. We're ready. You see, I can rotate, and I must rotate so that there is a clear seating. So I rotate these so that they are centered. And now I engage the second spring, and we can start to measure. Hold against here. Fix the spring, and we are finished. We can measure. Where do we take the tetrahedron? by hand underneath here and there, and then we can move it. No problem. Even we could move it only holding it on top. Even I could move it only taking it by one ball. I shouldn't do this. On these corners I shouldn't do it, though it works. Okay, where does the tetrahedron rest on? It rests on these rollers. I can actually take the rubber now away. But I don't do it. I leave the rubber normally underneath. On the other side, I leave either the rubber or there is a special steel plate that I put under the ball, because this ball stands on the table. So I should put it actually on a rubber, which is supplied here, and the steel plate is as well supplied. Last comment is this one. You see, and you might get afraid, what bends so much? No, this is an auxiliary rod. The spring force is introduced at the end of this rod. That is why there is this auxiliary rod. So the big rod which gives the length is not different. Here, the same thing there. That is where there are these rods for. At the end, you have the tetrahedron ready to be used. If you want to clamp it, you don't need to clamp it. You should clamp it on top of these two. If you rotate a little bit, nothing happens. If you have this too much rotated, then there is a relaxation process which might happen during your measurement due to the spring force. So you should have it actually nicely lined. Ready to measure. Thank you.